Hi and welcome to my OCR A-level biology revision session with me, Christine. So today's lesson I want to look at the reflex action. But before we do that, let's just remind ourselves about the nervous system. So we know the nervous system consists of our central nervous system, our brain and our spinal cord. And we know that we've got our peripheral nerves, which are differentiated neurons that are going to transmit electrical impulses rapidly through the nervous system. So if we look at a very basic impulse, then we know that we've got a stimulus that is going to be detected by a receptor, and we know that our sensory neuron is going to conduct the nerve impulse from a receptor to that central nervous system. We then have relay neurons which are going to transmit the impulses within the central nervous system. Now remember, our relay neurons have a very short axon. Because they have short dendrites and short axons, that means that within our central nervous system we have millions of these relay neurons to transmit the impulse. So to get all the way up the spinal cord to the brain and then all the way back down again, we are activating many relay neurons. We then will have the impulse passed on from the central nervous system to an effector through our motor neurons, and our effectors are our muscles and our glands, and what they're going to do is they're going to carry out the response, whatever that response is. Well, the reflex action is an extremely fast response. It's very few synapses involved. Now, this is important because it prevents danger without any conscious thought. So it's an involuntary response and it's innate. It's present from birth. It is the very simple pathway which is known as a reflex arc. So the stimulus detected by a receptor, a sensory neuron, passes the impulse to a relay neuron, to a motor neuron, to effector, to a response. Now the one that you need to know about is the knee-jerk reflex, which is your spinal reflex. Now, when the leg is tapped just below the kneecap, which is known as the patella, it's going to actually stretch the tendon, which acts as the stimulus. What you then have is that is going to cause the extensor muscles on top of the thigh to contract, and at the same time it's going to actually inhibit the muscles, the flexor muscles on the bottom, causing them to relax. Now this is important, and the reason it's important because muscles act antagonistically. We want one to contract whilst the other relaxes, and what that will do is that will cause the leg to kick out. So by having this sensory neuron, which is then going to connect to both the motor neuron and the relay, which will connect to the motor neuron, what that does is that ensures that the knee will kick out in a very specific way. So after the tap of the hammer, the knee will normally extend once and then come to rest. If there is an absence of this, for example, if this does not occur, that may indicate a nervous problem. If there are multiple oscillations, that may indicate that there is cerebellar disease. That's because this continuation of the leg kicking out is indicating that the reflex action is not working as it should be. So this is something that the doctor may use as a way of indicating a problem with the nervous system. And if you like this video, then please do click on the like button and subscribe to my channel. And if you haven't already done so, do check out my revision platform, www.aiqchat.com.